Our next speaker is going to be Peter Allen. Peter is a freelance developer working mostly on the front end, but who enjoys focusing on building rich, performant user interfaces with modern tools. When asked to describe himself in 5 words, he went with curious, hopeful, playful, critical, and uncertain. He believes that as an industry, we need to lower barriers by improving our tools, our documentation, and by building helpful and supportive communities. This is his first time speaking at Bristech, and his talk today is titled Re-rendering Perceptions with Svelte. Please welcome Peter.
Hey. Okay, so first we need to kind of fill in a bit of context about how building UIs works at the minute. So let's take a look at these shapes on a page, and let's just assume you wanted to update these shapes. So with my made-up API called the Shape Manager, which can be obviously shortened to the sham, we've got basically a description of these 3 shapes. So we've got 3 nodes, a shape, and a color. And that's it, a very simple interface. If we want to update these shapes on the screen, we just need to update the sham, and then our shape will update in turn. Now, if you wanted to do this a lot in your application, you're going to end up building some kind of an abstraction. And a naive implementation might just wipe everything off the screen and redraw everything to the screen. But that's expensive because I invented the sham and I've decided it's expensive. So we're going to need to kind of like be a bit more intelligent about it. So introducing the virtual sham. So what we want to do is we need to work out the minimum number of operations we can perform to get our sham in the state that we want it. So the sham is just kind of a mirror. The virtual sham is a mirror of the real sham. And if we were to update the virtual sham, now we've got a situation where we've just got a data structure in memory that's very cheap to work with. So we can go through, and we can compare each node. These structures are pretty much the same. They're a mirror of one another. And this first shape is obviously different, so now we can mark this for replacement. We can move on, and we can compare the next shape, which is obviously, as we can see, is the same, but the computer doesn't know that. And that's going to be ignored. We can ignore this node. It's important in terms of the shape of the structure, but we can just move on. And we can compare the final shape. And again, this is about performing the least possible operations we can. So instead of needing, because when you replace a shape, you have to destroy the existing shape, create a new shape, set its attributes, and then insert it at the right place. Whereas with this third shape, we can just change the color. So now we can update the sham. We know what those operations are. And then our shapes will all change. So this is a HTML page. Apparently it doesn't like my encoding. It's an enthusiastic HTML page. And that's how it would render in a browser. This is the code you would write to get this to display. And this is essentially the underlying structure. Now, the stuff in the middle is the stuff we want to write. It's declarative. It just explains our output. It's relatively pleasant to work with. But once we've sent that to the browser, that's it. It's just a string, and we can't do anything with it. We're going to have to drop down to this interface on the right. Now, this isn't an exact kind of copy. It's a rough approximation. The actual interface for these HTML nodes is huge, with hundreds and hundreds of fields, different nodes having different interfaces. But you can see that it's kind of remarkably similar to the sham from earlier, almost as if it were intentional. And the only big difference is that HTML nodes can have children, and they can have an arbitrary number of children, which are also nodes, which can also have children. So the issue is that if we want to update the page, we want to create a dynamic page where the user can interact with, then we need to drop down to the interface in the far column, but it's unpleasant to work with. It's expensive to kind of operate on. So we can take a similar approach as we did with the sham and the virtual sham. We can kind of keep a data structure in memory. We can compare it with the existing DOM. And then we can work out what those minimum changes are. So let's have a look at it in action. So we've got something similar to what we've just seen. We've got a title. We've got a list with 2 list items. And we've got a button. So if we were to add to our list, we can see we can compare what we want to show with what we've currently got. And we can mark these for insertion. And we can keep doing it. And likewise, if we want to remove anything, we can also remove those things from the page. all the while making sure we're not doing too much work. We're not redrawing anything else. Everything else is left the same. And likewise, if we wanted to update just an attribute, then we can just update a single attribute. It's also important that anything that's tracking the DOM can handle kind of clicks, so we can handle clicks as well. So this seems like a good thing. It's a good idea. You know, we can perform the minimum amount of work, but the issue is every time you change any state in your application, this whole process starts again. We have to build the data structure. We have to compare it to our existing data structure and reconcile the differences. And only then can we update the DOM, which is a step that you can't skip. This is all in addition to updating the DOM. So, and this is how the majority of UI frameworks work. If you want to build interactive applications to the web, this is the kind of process that you have to go through. So this talk is called Re-rendering Perceptions with Svelte. Is there an alternative? So Svelte is a component framework. You can build your UI from small little modular pieces that you can then compose together to create anything you want, just like React or Angular or Vue. It was written by Rich Harris, who is the author of Rollup. He works at the New York Times as a graphics editor. He also wrote a framework before Svelte. So this is Svelte code. This is something you might write. It looks an awful lot like that kind of simple HTML that we said we wanted to write. I said we wanted to write. And this is what Svelte spits out. So there is no virtual DOM. There is no process of creating data structures and reconciling the differences. If the name value has changed, then just update the data attribute of a text node, which is, as you can see, it's pretty straightforward. So how does it work? Well, Svelte is not a runtime library. It's not a library that the users have to download and parse, and then you just use the API. It's a compiler, so it operates at build time instead of runtime. So this is the actual code. You do need to define your variables up front. And essentially what Svelte does is it takes a template like this, it parses it to an abstract syntax tree, and then it analyzes that syntax tree to work out the relationships between the different values. So here, Svelte can see, we've got letName, Lilitha. So that's a top-level variable. It's in scope of everything. So this is treated as component state. The compiler can then see that it is used as part of the value of a text node for that first-level heading, and then it is reassigned. And so Svelte knows that, well, if it's used as that text node, whenever the value of name changes, I just need to update the text content of that H1. I don't need to do anything else. That variable isn't used anywhere else. We can work out statically at build time what we need to change, and we don't need to go through that expensive process of reconciling changes at runtime, which the user has to pay for. So Svelte is a compiler. There is no virtual DOM, and this depends on your experience with other UI frameworks, but Svelte components don't re-render. So if you've ever used React or anything that has a kind of a similar render model, you might be familiar with the idea of UI as a function of state. And this is the idea that you put some inputs at the top of a function, you do some work, and then you return the virtual DOM that you want to render. So if you change those props, well, the function runs again, top to bottom, and then it spits out a new virtual DOM. Svelte doesn't do that. The component runs top to bottom once when you mount it. If you create another of that component, then obviously that one runs again, so it's per instance. But the component itself, it doesn't keep re-rendering, which means that you can kind of respond to individual values rather than having to recalculate everything, even when anything changes. But that means that we have a problem when it comes to responding to updates, because if nothing re-renders, how do we make an interactive application? So, and this is the idea of reactivity, and there are broadly two kinds of reactivity. The first and the simplest is how do we tell Svelte that something has changed? How do we tell it that a piece of that component state has changed? And in Svelte, because we're a compiler, we're not restricted by the semantics of JavaScript. So this is how you tell Svelte something has changed, or this. or this. Any assignment operator will kind of signal to Svelte that this value has changed. If anything depends on it, you need to update that, and Svelte will take care of that in the background. But there's another kind of reactivity. Oh, sorry, an example of the last. So we've got this. This is the. Let's make this bigger. This is essentially the code that I from the example earlier, and we can see that we've got the top level variable. So that's component state. That can be used across the template. It's used here as the text node, and we've just got an assignment. It's just name equals Frank. And if we click on this heading, it will just change. This is kind of the basics of how a Svelte component works. It's basically a HTML with some extra functionality. So that's that's a reactive assignment. That's how you tell Svelte something's changed. But there's another kind of reactivity, and there are lots of clever examples, but I like to think of it like this. And so this is obviously a chalkboard. And in this chalkboard world, we've got these chalk houses. All the houses are unique, obviously. Got a yellow, a green, and a blue one. And we've got these dogs as well. Every house has a dog. All unique, as you can see. And we've got a road in chalkboard world, and we've got an ambulance. So these dogs, I don't know if you can see those circles, but these dogs have what I like to think of as like a range of reactivity. So anything that comes into that range, anything disturbing, then those dogs are going to respond. Everything's quiet at the minute, so it's fine, but there's been an accident. And so the ambulance, obviously something terrible is about to happen. The ambulance is going to enter this dog's range of reactivity. As we know, the noise from a siren comes always from the light. And so this ambulance is going to kind of like head off, and this dog is going to set off the next, This dog is going to set off the next dog, which is going to set off the next dog. And it's going to set off this kind of chain of events. And you can think of this as essentially a graph. Each one is linked to the next. You have a set of dependencies, and if something changes, then if one of those dependencies updates, then you will too kind of update. You will react, and those dogs might not, they don't have to be told, you need to check if something's changed. They just kind of know that they need to change. So maybe a more formal example, a spreadsheet, probably the classic example of reactivity, and probably the most widely used programming language in the world. And we've got some totals, so these totals correspond to the rows across, and we've got kind of a grand total. And if we update one of these values, then all the other values will update, all of the dependencies will update. And we can kind of we can create new values like this. And again, if we change the values, they will update. And we can visualize this. So let's look at the inputs and outputs. So here we can see that the A1 cell, it kind of contributes inputs to the D1 cell and to the C5 cell. And we can see this across here as well. And this value has inputs and outputs. And we can start to see a relationship that, so whenever any of like A, B, C, A1, B1, C1 change, then D1 is going to update as well, and so is obviously D4. So there's this kind of relationship. But this isn't really a thing in programming languages. Values don't do this. They don't keep track of whether or not the dependencies have changed. So here we've got a clock. It doesn't work. And it's not because time is broken. And the problem is basically if we see here, we are reassigning on a timer. So every second, we're creating a new date. So the date value, the time value here, is updating. But the time value isn't being used. So there's nothing really to update because Svelte components run top to bottom, and they don't re-render when a state changes. These values are stuck at the initial value. So what we need is a way to tell the compiler, this is a reactive value. When your dependencies change, you should update too. And here the dependency is clearly the time value. And we can do that just by marking them as reactive. And now the clock works. This is a reactive declaration in Svelte, and essentially it could be any code. This is an assignment. You can actually remove these initial definitions as well. They will be injected by the compiler for you. And this is just a way of saying if any dependency changes, rerun. This could be a function, it could be a side effect. So this could be, so in this case, it's kind of like a computed value, but it could be equally just a side effect. It could be a subscription or something like that that you want to run, or an animation, anything. So the benefits of being a compiler. One of the benefits of being a compiler is that you're not kind of constrained by things that it makes sense to do at runtime. You have a lot more space in which to solve different kinds of problems. And obviously we've seen the static analysis kind of benefits of no virtual DOM, but we can produce smaller bundles. Because Svelte's analyzing your code at build time, it can work out which kinds of things that you're including. If there are features of the framework that you're not using, then they can just be discarded. They won't be included. And obviously, if you ship anything to a user, all of that code has to be downloaded and parsed before anything can happen. It doesn't matter if you aren't using those parts of the API. They're still going to be paid for in some way by the user. So we can produce smaller bundles. We can also have a rich feature set. If you're building a runtime library, you have to be very careful about what you're including, because all of it has to be loaded and parsed. But we don't have that problem because we can just not include that code. If you're not using animations or transitions, if you're not using all these things, then we won't include them. So simplicity is a little bit subjective. But the aim is, by not being constrained by the language semantics of JavaScript, which don't have any kind of first-class support for reactivity, we can kind of rewrite things. So on average, Svelte components are smaller than equivalent React components, for example, or even. So this reactivity system is new in Svelte version 3. They're much smaller than even Svelte 2 components. But the test of simplicity, I guess, is in looking at some examples. And so this is a basic component. This is roughly what we've seen. This is how the component-based architecture works. You can nest components within components. And this way you can compose your functionality as you wish. And this little equal sign will turn into with our assignment there, updating the page, just letting Svelte know that it needs to update. So here we've got logic blocks. So logic blocks in Svelte use this hash if. There are others as well, but that's just a way of visually distinguishing them from one another. So it's clear to say what is a block of logic and what isn't. And obviously we can put conditionals in. It looks a bit like handlebars, but we don't have the same limitation as handlebars had, if you've used that before. And we've got lists. Some nice pictures of penguins for you. And this is just a list. This is just a list of different types of penguin. You'll notice at the bottom here we've got, I don't know if you can see that clearly, but we've got an accessibility warning. So it says, and this is another feature of Svelte, if there's still work to do, we don't cover all kind of accessibility, but you're supposed to use alt attributes on images, so we're not using the description here, so we can pop that in, and this will give you a compiler warning in your console, and we can just put the description in there, and that will go away. So you get little warnings, you get other warnings about things like using autofocus and such. And here we're just each penguins and we're deconstructing this object here. And then we can use those values and it won't loop. And we can also key lists if we need them to be unique references. We can await promises. So if you need to do any simple network requests, we can await promises directly in the template. So if you're working with native fetch and stuff, you can resolve promises. This is a fake promise, obviously, that I'm just force resolving. But it is a promise. And if it's rejected, we can catch that here, and we can kind of log the error. And so you can handle those errors directly in your templates. We've got events. So this is a DOM event, an on-click. So we can just put an on-click, and on: supports any built-in event. It also supports custom events if you're dispatching your own custom events. And we just include the handler. It works much the same as a native click handler does. And we've also got this on hello. Hello clearly isn't a native DOM event, but this is an event being dispatched by the component itself. So this is one way of kind of facilitating cross-component communication. Obviously, this goes back up, whereas props go down. You don't have to use events. You could use callbacks, which keeps the data flow in one direction if that's something that's important. And we can see that we can send payloads with those events as well. So probably a big feature of Svelte that people seem to like is bindings. So forms are really awkward to work with, and you often need to control the value of your forms and use those values in your components. So here we've got a couple of forms. We've got a text input, we've got a number input, and this is a date input. And as you can see, we're kind of outputting that there. So here is the input, the text input, and we're binding to a value. So we're binding to the value property of this element, which is where essentially the content is stored. And because we're binding to it, what we're doing essentially is we're keeping the value of the input in sync with the text value variable. So obviously, if I kind of start typing here, it will just automatically stay in sync. And likewise, if I were to update the variable itself, it would also update the text input. We can do the same with numbers. We can do the same with the native date picker thing, which is nice because forms are pretty awful to work with. So actions. This is an action, and an action is essentially a life cycle for a HTML element. So you can HTML elements have a life cycle. They're mounted to the page. They're removed from the page. And you can kind of tap into that. And this action is a function. It's just a plain function that you can kind of share around. It takes in the node, and you can do what you want with it. And it returns an object that can optionally have, destroy and update kind of methods. But essentially, this just allows us to kind of hook into any. So we just use this action, and we can kind of create more of these if we want to. And each one will have this life cycle, and the penguin will obviously walk across the page like so. Svelte has first-class support for transitions. So when you bring in elements in and out of the page, transitioning them in can be a bit of a pain. Transitioning elements in is okay because you can just kind of put the thing on the screen. You can kind of make it, you can hide it, you can put it where you want, and then you can animate it in. But animating things off the page is kind of awkward because the framework wants to just remove that node from the page. So as soon as you kind of change the state that says that this thing shouldn't be here anymore, it will just try to remove it. But you need that kind of removal to be deferred until your animation is complete. With kind of first-class support for animations, this isn't a problem because Svelte knows that an animation is being used. So we'll wait until that animation has completed before we remove it from the page, and we've got an if show. And we just add a transition directive, and we're using the blur in this case. And then we can pass in some parameters, so durations, amounts. You can pass in custom easing functions, and Svelte also ships with a bunch of, pretty much all of pen as eases if you do a lot of animation work. And you can just animate in and out like so, and you can add delays. And you can also write custom animation functions. You can do them these compile down to CSS keyframe animations, so they're about as performant as they could be. You can write custom ones. But there are a bunch of built-in ones as well. So here's on the animation topic, we've got a simple grid here. So I can add and remove values, I can rotate them, I can reverse them, and I can shuffle them. But it's not very helpful. You can't see where anything's going, and it would be nice if we could animate this. So this is a kind of a relatively common thing that people like to do is flip animations. So this idea that you calculate the start and end positions, and then you can transition between them to keep your animations as performant as possible. And they can be a bit annoying to write. So Svelte supports them out of the box with the animate. I can't type. And all we need to do to make them work is find our list, add the animate directive, and the flip function. And now we can automatically animate them all, like so. And it's just one line of code. Another, probably a really important feature is not just compile time reactivity within an individual component, but also runtime reactivity. So we've got this, this store concept. And a store is essentially just a wrapper for a value. So this operates at runtime. So this is runtime reactivity. So this is just kind of JavaScript. And it's essentially, if you're familiar with RxJS or observables, it's basically an observable implementation. But it's essentially just a value in a box. And it's in a box so that we can be notified of when that value is changing. So you can subscribe to this. In this case, we've got a writable. And we've got a derived up there, which takes a writable and can compute a new value from it, staying in sync at all times. And we can use this. Here we're using we're using these values in different components, and then we can import them both here as well. And they will always stay in sync. And this is in the kind of the parent components, and these are in the child components as well. And the important thing about stores is, normally, the way you kind of use a store is you'd have to subscribe to the store. And then if you want, when you're done or your component's like being removed from the page, you've got to unsubscribe from the store. If you want to kind of access that value, you've got to somehow unpack the store. But Svelte takes care of all of this for you. All you need to do is take your store, which is just an object, and just put a $sign in front of it. And this gives you access to the value inside the store. Likewise, if you wanted to set the store, you can just assign directly to the $sign value of the store, and it will automatically update, rather than needing to call its set method, which it does have, which you can call if you want. It also has an update method if you needed to pass a callback to compute the next value. But stores aren't so much a feature as they are a provided implementation. The important thing about stores is the contract between the Svelte compiler and the store API. So as long as a store returns a subscribe method, it's an object that has a subscribe method on it, it will work with Svelte. So for example, RxJS observables just work. You can just use them directly in a Svelte component without any other setup. But also you can implement your own stores. You can write whatever custom implementation you need. As an example, so Svelte also has these tweened and springed stores. And they're just stores, but inside they kind of interpolate values. They use request animation frame to execute once every frame. And this is a tween store. And this is the Ebbinghaus effect, where the size and proximity of neighboring shapes influence your perception of other shapes. And this is just a store. This is a custom store that we can just use these values directly in the template. Because there's no virtual DOM, we can just stuff values directly into the attributes. So if you want to change the X and Y values of SVG circles or something, you can just stuff those values in. In other frameworks, you usually have to drop down to the native web APIs. We've got another example. This is a spring. Again, this is just a store that springs values using spring physics, and we're just tracking the mouse move. And we've just put the XY values directly into the template. And this is an example that David Henschel put together, and I think it was for React Spring. But we can achieve the same thing with springs. You've got your nice spring physics. And these are just stores. So you could write your own custom implementations of stores, as long as they observe the contract. It's an object that has a subscribe method, they'll work absolutely fine. So, if you want more information, we've got API documentation. We have a chat room, which is the Discord chat room. We have an interactive tutorial that you can try live in the browser. We have an interactive REPL, which is essentially what I've been using for these examples. So you don't need to install anything. Obviously, it being a build time library means that there is some setup, but you can just try it live in the browser. Oh, I've gone off screen. And I'm Penguin on GitHub. Thank you.
Sort of typical applications.
Yeah, there are lots of benchmarks. And they're kind of problematic because it depends what you're doing. And it depends on a number of factors, like our really long list rendering is not that great. But if you need to update, like I find myself generally needing to update things very quickly. Not necessarily lots of, so, you know, something rendering in 100 milliseconds is no good, because if it isn't under that 16 millisecond one frame threshold, it's too slow and it's going to have poor performance. So that's often my issue. Obviously, if you are rendering really huge lists, I would argue that you should be using a virtual window instead. You should be only rendering the things that are on screen, because there is a point at which just rendering 1,000, 2,000, 3,000 DOM elements, well, it doesn't matter if you don't have a framework at all. That's going to be expensive. That, you know, any work that you do with the DOM is going to be expensive. The important thing is not introducing too much overhead. In terms of performance, Svelte is particularly fast at mounting, because the size of the bundles is small, and so the parse time is also quick, and because there's no kind of like virtual DOM diffing, it does tend to mount very quickly, which in my experience is the most important thing, is getting things on the page and interactive as soon as possible, because you don't want users to bounce. Subsequent navigations, you could always lazy load them in and preload them and stuff like that. So,
Right.
Hi. I was just wondering what like the ecosystem is like, because obviously in terms of something like React, I guess you've got so many tools and libraries and stuff. Like, could you start using it in production now, or are there still some kind of limitations on that side?
yeah, the ecosystem is obviously much smaller than React or Vue are probably the ones that have got the richest ecosystem right now. The biggest issue is probably things like, I mean, to be honest, the biggest issue is probably that people haven't quite worked out what the best patterns are for, you know, doing different things. Obviously, because everything is statically determined, there are some things that you can't, well, that are more difficult to do, or you need to take a different approach for. So, like things like component libraries are starting to pop up. We've got testing tools that are okay. You test Svelte kind of the same way you test anything. You know, if you use Jest and if you use those kind of tools work just fine. There are adapters to get things working. There are obviously a lot less. There are a lot less things like one of my favorite React libraries is other kind of like the gesture libraries, and there aren't as many of those kinds of libraries for Svelte. It is growing. Tooling is, you know, not as good, so TypeScript support is probably the biggest thing. It's like currently there is no TypeScript support for Svelte components, and it's the #1 request, and it is a high priority, but it isn't there yet. And because obviously we've got this custom syntax with custom semantics, that's obviously more challenging. But we think it's possible, and it will come in time, but yet the ecosystem is definitely smaller.
Yeah, I thought the presentation itself was like really cool. So I was just wondering like what you used to build the actual presentation.
This is all built in Svelte. So the code examples are Svelte inside of a Svelte app. So that's what we've got running on the Svelte site, both the REPL, which you can just run stuff, and the tutorial and some examples and stuff. And it bundles inside of a worker in the background, so it hopefully doesn't block. But yeah, it's all in Svelte. I don't think I used any external libraries, really. There might be one or two in there, but like things like all the animations, all the transitions, that's just Svelte's animations, Svelte's transitions, the Spring and Tween stores, all built in. So from my point of view, one of the things I like is I don't like managing my dependencies, especially not in the JavaScript ecosystem. So not needing to reach for a dedicated animation library is nice, and I do a lot of animation. Only having to reason about animating values instead of attributes of DOM nodes, which can be confusing, is really, really nice. And I can just, okay, I'm just animating a number. I can just plonk this in somewhere in the DOM, and it will update the things that I want it to update. And likewise, if I needed to animate RGB strings or something from one to the other, I can provide a custom interpolator for my kind of tween stores or something, and it can interpolate those values as I go. So not needing to bring in all kinds of libraries is, for me, one of the benefits of having a feature-rich framework, but not having to pay for features that I don't use.